So we're going to look at energy level diagrams. It's a different way of looking how a reaction proceeds. On the vertical axis, you've got the energy, which is the potential energy of the chemicals that are present, and the energy change that takes place when reactants turn into products. On the horizontal axis, you've got a qualitative course of a reaction, not specific time intervals. And this one here is an exothermic reaction, and going from reactants to products, vertically downwards, that's the amount of energy that is given out. Examples in everyday life would be any fuel that is burning. Obviously, we use the heat to do work for other things. We can also have an endothermic reaction where the potential energy of the reactants is lower than the potential energy of the products that are formed. And so energy has to be taken in for the reaction to take place. Examples in everyday life: photosynthesis, using sunlight for the energy, cracking hydrocarbons, breaking long molecules down into shorter ones for different uses, and thermal decomposition reactions. If you heat calcium carbonate, you'll end up with calcium oxide and carbon dioxide. And if we're going to look more closely at the energy level diagrams, we're going to use the exothermic reaction, and the difference in energy between the reactants and the products is the heat of the reaction, also known as the enthalpy and designated by delta H. We've had a slope going downwards, but actually we're going to look more closely at the energy involved, and there has to be energy taken in. The top of the peak is your reaction intermediate and has higher energy than that of the reactants or the products. And going from the reactants up to that peak is the activation energy. How much energy has to be added for that reaction to occur? Now, when you add a catalyst, you get the dotted line. The energy required to make that activated complex in the presence of catalyst is lower. So adding a catalyst lowers the activation energy, makes the reaction easier to take place because you're adding less energy, and the reaction will occur faster.